Hey everyone, so in this particular video we'll be writing the training function, and if possible in this particular video we can also go on to write the validation function. I'll be writing it under one loop only. We had written till over here, so this is again I have rerun the kernel, so you are seeing a different image over here. And in the last time till we had written till optimizer, right? So we had written the model and also the optimizer and loss function. So let's start with the training loop. The first thing, we need to have certain ways of keeping track of all the losses, because we will be doing training and validation together. I'm creating two basically lists which will have our training and validation loss for all the epochs. Okay, so for, let's say, the epoch, so as I had said, we are going to use 5 epochs. We're going to have 5 epochs, so I'm going to say in the num epochs. So as you can see over here, we had said num epochs equal to 5. Okay, so what you're going to do over here is you are just going to keep it like this, num epochs, and inside what you're going to do is you're going to write certain other variables so that we can have track of all the losses for one epoch. So this is for all the epochs and this is for each epoch. So train epoch, the first one is going to be the train epoch loss, and let's initialize it to 0. So what this will do is in every epoch it will see what it will keep on adding the training loss. Okay, what also we need, we also need train, we need total train samples. Why? Because we need to see how many samples have we got. Okay, otherwise we'll not be able to take the average of this, right? So we will need that thing also, and after that we will also need a variable to see how many of our predictions were correct. Okay, so total correct samples, or total train correct. Okay, total train correct. So again, this will basically keep all the, it will keep track of all the correct classifications. This will keep all the track of as many of all the samples, and this will basically keep track of the losses per epoch. So let's start with our training loop. So the thing I'm going to say is over here, I'm going to say for, and in here obviously we are going to say images and labels. Why? Because we are taking it from in train loader. So if you remember, in train loader, over here we had defined the train loader over here, right? So this is the data loader. Okay, so it will give you two things. It will give you images and labels. Okay, so once you're done with that, what you can say over here is you can say total train samples plus equal to, so how many samples are there? Images dot shape of 0. Okay, images of shape of 0. That is, now you can say overall in every epoch, since all the images will be passed, so you can say 85,000, whatever the number was. But again, you know, I'll try to keep it more general. Fine. After that, what you need to do is, we had a fin model, and we will keep it in the train mode. Why? Because there are two modes, okay, in PyTorch. So there is train mode and there is eval mode. Eval mode, again, it stands for evaluation. So whenever you are doing evaluation, you should have this mode activated, and when we will be doing validation, we'll obviously will be using that. Okay, so after fin underscore model dot train, which will put the model in the training mode, we need to see if the torch is available, or the CUDA is available. Torch dot CUDA dot is available, which means the GPU is available or not. If torch dot CUDA is available, what we need to do, we need to send the images as well as the labels to the CUDA, what to say, GPU. Okay, so labels dot to device. Okay, so these two things will be done. Having done that, what you need, you can basically pass the images to the model. So I'm going to say fin model, and in bracket I'm going to give images. Okay, after that, what you can do, you can find the loss. You're going to say loss underscore loss function, loss equal to loss underscore function, and you have to pass two things. You have to pass the output, because the loss will be calculated, which is the cross entropy loss, will be calculated between the output and the correct labels, right? So you're going to say this. Okay, once you're done with that, loss is calculated. Remember, we have training loss for each epoch, so we have to add it over here. So train epoch loss plus equal to loss dot item. So item will basically, since this loss is another tensor that is on the GPU, you don't want all of that, you don't want to detach right now. Okay, so what you do is you just write loss dot item. It will just give you the accurate loss, the integer basically, or the float, whatever. Okay, whatever the number, the new number. Okay, it can be, it will definitely be a float, but whatever the loss is there, it will have that, and it will append to the train epoch loss, which is basically trying to capture all the losses during all the epochs. Okay, after that, the basic stuff, you need to zero out the gradients, zero grad. Why? Because we are going to do backpropagation, loss dot backward, and finally optimizer dot step. Okay, so these three things are common in all the to say your programs. Okay, when it comes to backpropagation, this is how you do backpropagation. Now what you need to do is, we need to find, since we have found of your training loss, we also need to find training accuracy, and for that I'm going to put the model in the eval mode. Okay, so eval mode basically turns off certain things that are, like for example batch normalization, that we do not need during the testing inference phase. So this and dropout and all those things which we want only during the training but not during the validation or testing. That's why what we do over here is we put the model in fin.eval or model.eval mode. Okay, after that we don't want to do backpropagation, and hence we will say torch.nograd. Okay, this will be there. And now we need to do two things. First of all, we need to find the maximum index, and I'll have to show you why, but first I'm going to write it. Okay, so torch.max, and max of what? Output, and dimension equal to 1. Don't worry, I'll explain this line. And after that we also need to find how many samples were correct, right? So remember, we had a variable over here, total train correct. So I'm going to use that particular variable, total train and correct, okay, plus equal to. So what we are going to do is, we are going to find indices double equal to labels, and we are going to sum that, and then again take the item of that. Okay, now let's go and understand this particular line, because I think this is important to explain, right? So the line that we had used were torch max output dimension equal to 1. Okay, so let's say your output is, I'm just going to have 4 of them. So let's say your output was 0 0.4, 0 0.6, 0 0.3, and whatever. So this is unnormalized in our case right now. So because the softmax will not be added right now, so output is basically whatever you are getting from your neurons at the final layer. Okay, so this is your output, right? You're getting from the neurons of the final layer. So these are unnormalized. Okay, so one can be like minus let's say 0.8. Okay, so this is one, but this is a matrix, right? Because this is for one particular sample. So let's say there are 4 neurons and then there are 3 samples. Okay, so there is a value over here also, and then there is 1 2 3 4 here again 1 2 3 and 4. So there are 4 columns over here and 3 rows over here. So this is a 3x4 matrix. What we want is, for each sample we want to find the maximum. You see over this is minus, huh? So what is the maximum over here in this particular row? Because this is an example, right? The maximum is 0.6, right? What is the maximum? 0.6. But what is the index of the maximum? That's why I said axis equal to 1. Axis equal to 1, because axis 0 will be found this way. I don't want this way, I want this way, right? So I want to see what is the maximum in particular rows, and that's why axis equal to 1. Very important. Okay, so axis equal to 1, the maximum is 0.6 in this particular row. So max will be 0.6, but we don't want the max. Why? We are interested in the index. So what is the index of that? So if you know how to label the index, 0 1 2 and 3, obviously this corresponds to the first index, so the index is 1. Same thing, there will be some values over here, and let's say your highest is over here. Then in this case your max, I don't care the max, what I want is the index. In this case the index will be, 2, right? So this is 0 index, this is first index, and this is second index. In this case, let's say it's over here, then index will be 0. So for every sample we have found the position of the maximum index, and that is the What is the position of the maximum index? That position is basically the predicted class. I hope you have seen the video of softmax and what to say, all that. Okay, softmax and cross entropy, all those videos, theoretical videos are already there on the channel. Okay, so I hope you understood the concept. Now what this one is doing over here, so I hope you got the first function. Okay, after this, what you are trying to do, very simple. Okay, what you are trying to do over here is you are finding those index, and let's say those index actually match the labels. So this double equal to will give you a bool array. Okay, so if those indices match, so this index over here matches the label. For example, let's go over here, and let's say your indices, whatever whatever we got from here, let's say. So indices, whatever we got in the first case, we got the index of 1. In the second case, we got the index of 2, and third case index, we got the index of 0, right? Index 1, index 2, and index 0. So our indices vector is what? Indices vector is 1, 2, 0. Let's say the correct labels, because labels is correct, the correct labels was 1, 3, 0. So how many of them are correct? So this is obviously what? This is predicted, right? Because this is from the model, and this is real. Okay, ground truth. So you can see this is correct and this is correct. Model said class 1 and the label was also class 1. Here the model said class 0, here the label is also class 0. However, here not. Model is saying class 2 and this is saying class 3. So in here, since they are equal, it will become true. Here they are not equal, this becomes false, and here they are equal, this becomes true. Okay, after that what you do? You do a sum of that. You see, you do a sum of that. So in Python also, true is equal to 1, false equal to true, false equal to 0, and true equal to 1. So if you sum all of that, 1 plus 0 plus 1, that will become 2. Okay, and you must basically take the item, which means you are just going to take that particular value. Okay, and you are going to append it in the, or rather add it to the number of correct classifications. So I'll keep it till here in this particular video, because in the next video we are going to implement the validation function, and I need you to be, you should first go through this particular video. If you are having some confusion, go back again, watch the video, rewatch the video, so that in the validation step it's not that difficult, because most of the things will be just copied from here. Okay, so I hope you like the video. If you like, please like and subscribe. Thank you very much, and bye.